My name is Barry Stone. I am from International Paper in Georgetown, South Carolina. Anybody ever been to Georgetown? Beautiful downtown Georgetown, right? We sit right on the East Coast, between Charleston and Myrtle Beach. Beautiful place to be. I work for old stinky paper mill. Anybody use paper this morning? Has anybody used paper? All right, I did too. Of course, it was wiping sweat. I'm nervous as a cat, but I'll be all right in just a minute or two. I'm going to try to stay out of the screenshots, guys. Let me tell you a little bit about myself. Like I say, my name is Barry Stone. Been working with International Paper now for 22 years. And started our UE program after I attended a level 1 certification course down in somewhere in Florida, Crystal River, Florida. Found out that it was a valuable tool. Now, I am an IE by trade. Anybody know what an IE is? Uh-oh, this ain't good. IE stands for instrument electrician, okay? I still put on my boots every day. I still put on my FR clothes. I still go to work. However, I am also an IE, instrument electrician, precision maintenance instructor for International Paper. I've had the privilege of going all over our mills, all over at least the East Coast, from New York down to Alabama. Spent a lot of time in Alabama. That ain't where my accent come from. But it's been a pleasure. We teach 3 courses. We teach instrument electrical precision maintenance. Okay, we talk about how to better control your process. That's a whole different meeting. If y'all want to talk to me about that later, we can do that. We teach control valves. I heard control valves mentioned several times. Okay, Dr. Neal mentioned control valves yesterday. Okay, I've heard other people mention control valves. That's another course. I also teach something called EPD, electrical power distribution. Okay, got started in EPD back when I started with International Paper. Up until then, the highest voltage I ever dealt with was 480. Okay, that brings up a question. My presentation says, well, it doesn't say, that I'm going to talk about high voltage and the IR camera and the UE gun. What is high voltage? Somebody tell me. I don't care. Somebody, anybody, any electricians in the house? Come on, electricians. Any electricians in the house? Electrician? Good. 600 volts? Actually, I'm sorry? 69,000? See? Okay. What I consider high voltage, personally, what I consider high voltage is anything that will shock me. All right? I deal with 115,000 volts all the way down to 24 volts. That is the nature of my job. Okay? So whenever these guys approach me about doing a high voltage UE/IR presentation, I said, okay, this ought not to be hard to do. I am proud to say that I had to look long and hard at our facility to find an issue. I did. I had to go outside the facility, for goodness sake. All right? Ultrasound has saved us millions of dollars. My boss, my former boss, not the current boss, my former boss handed me the UE gun and said, here, Barry, somebody got to know how to use it. All right? Didn't know what it was. Had no clue. It was cool too, looked nice. This is a UE 10,000. He said, here, go figure out how to use it. Well, I went to the course in Crystal River, learned a lot. Came back to the mill and started looking. Let me correct that, started listening, okay? I heard somebody say the other night that the way they found out that they could hear real good is close their eyes. Hey, kind of makes sense. I intend to try it, okay? But by coming to this conference, I've met a lot of nice people. I met a customer of International Paper, okay? All of y'all are customers of paper mills somewhere in the world. But I met one of our direct customers, okay? Right over here, he works for P&G, works for Procter & Gamble. They are one of our major customers, and it was nice to meet them, okay? We talked about a few things, and got a couple of things I'm gonna take back home with me. All right, enough about me. I counted the electricians. I saw 3, I think it was. Saw 3 electricians total. How about mechanical guys, rotating equipment? How many mechanical guys we got? Okay. How about other than electrical or mechanical? What do we have? I'm sorry? Friends? Okay, friends. My Spanish ain't good, all right? Anyway, what I'm going to talk about this morning, guys, is focused on electrical. But I got my friend up here this morning to put this picture up. That's me, all right? That's me. This was an afterthought this morning. I was sitting out on the balcony drinking my coffee. I said, you know, talking about high voltage and rotating equipment, okay, I would be remiss in my duties if I didn't talk about safety, okay? All of you that can see that picture, that was me on my 50th birthday, all right? That was on my bucket list. I wanted to go skydiving. Brian Abbott is the guy that I jump with. I jump tandem. And Brian had just started up his brand new business right near home. I was his first paying customer. So we got in the airplane. Everybody's ridden in a Cessna. Has everybody ridden in a little Cessna, a little 4-passenger Cessna deal? It's a little buzz airplane. All right, it's a little tight and quaint. It's lots of fun to ride in a Cessna. Brian took the doors off. All right? I'm sitting here in this Cessna, flat on the floor, with my legs straight out in front of me. Picture this now. I've never jumped out of an airplane. I'm 50 years old. I'm this guy's first paying customer. I'm sitting in this airplane, flat on my backside, holding the cover that covers up the tail section of the airplane with my feet, all right, because the wind's blowing it out, holding the panel to the side of the airplane because the wind's about to blow it away, all right. We get up, it was cloudy that day, it was a beautiful day. The whole way up though, this is a point I'm going to make. The whole way up, Brian was checking buckles, all right? Are you attached? We got to be safe. I can't let you fall. Thank you, you know, kind of thing. But anyway, he was checking buckles. He was doing his safety checks. I'm going to finish my story now. We get up 10,500 feet, okay? I look out the open door of the airplane. I'm not afraid of flying. I love it. I love to fly. Helicopters, airplanes, it don't matter as long as I'm flying. Look out the door of the airplane, it's cloudy, and I see a hole in the clouds. And through that hole, I saw Andrews International Airport. They got one airplane, all right? And I'm fixing to jump out of that one. So I tell Brian, I said, Brian, I'm ready, there's the airport. He said, cool. He checks my buckles again. All right, he's being safe. We roll out. He says, okay, Barry, on 3, we going. Okay. And you can imagine my anxiety at that minute. All right. He says, okay, 1, 2, 3. And we went. All right, on 3. He didn't say go after 3. We went on 3. I wasn't expecting that. 0 to 130 miles an hour instantly. Just that quick. Cool. Thrill like you wouldn't believe. Here we are sailing through the air because we were free falling. Okay? We were skydiving. Okay? We weren't hooked up to a line. We fell like that for about 24 seconds from 10,500 feet. All right. Awesome. Awesome. Biggest thrill I ever had in my life. Driven race cars. But that was the biggest thrill I ever had. But when the chute opened, big old pretty chute. It's kind of hard to see right there, but it's multicolored. All right. Brian looks up and says, good chute. All right. The whole thing is, okay, he made all his safety checks before we ever exited the airplane. Guys, whether you're dealing with rotating equipment, whether you're dealing with electrical, high voltage or low voltage, okay, please be careful. All of us know where there is rotating equipment or electrical issues in our facilities that will kill us. All right, they will eat you. They don't care. They don't have a conscience. Okay? I've lost one good friend. I don't want to lose any more. Please be careful. Okay, enough about safety. This is the tools that I use. Okay? We have the UE 10,000 probe, and I actually use a Fluke TI-32 infrared camera. Okay? It may not be the latest and greatest, but it works well for what I do with it. Okay? I do high voltage inspections. High voltage being 115,000 volts down. I normally stop right around 2300, and the other guys in the mill take over from there. Okay? We found issues when we first started our program using the Ultra probe. We found issues with, like I say, 34,500 volts, 13,800 volts, 2,300 volts. I found issues at all those places. Things that we couldn't see. All right? Close your eyes. It's things that you can't see that were going to get us. At the Georgetown Mill, it was built in 1937. We celebrate our 75th anniversary this year. Woohoo! Right? They're going to take us out to the ball game. Anyway, it was repurposed in the mid-1980s to manufacture something called bleached product. Bleached product, guys and girls, is white paper. White or colored. We're a 365 day per year mill. We run 24 hours a day, 365 days a year, with the exception of our annual outage. And now, for the past few years, our annual outage, they've actually started running parts of the mill during the annual outage, and we have to be real selective about what we're shutting down. We currently have 3 generators capable of producing anywhere. We got one that produces 32 megawatts, 44 and 44. We got 3 generators. We run 2 power boilers, 2 recovery boilers. If you're not familiar with the paper mill cycle, the way we do things, okay, we recycle everything. Okay? These generators provide most of the power needed in our mill. All are operated with the majority of the fuel being generated by the process. If it'll burn, we'll burn it. Okay? From TDF, which is tire-derived fuel, chipped up tires. We've got permits to burn that. Okay? Chips. Something we call black liquor. Like I say, this is things that we'll, if you want to talk about the paper process later, we can. But we generate all of our own power. We do have the capability of purchasing power from Santee Cooper, which is our local electrical supplier for the area. Our mill generates enough power to run everything that we've got, including all our outlying areas, okay, and the city of Georgetown. We generate enough power where we can actually run the city or supply power to the city of Georgetown. So maybe now you understand why it's so important that we have a valid electrical predictive maintenance program, right? We've never had to supply the city of Georgetown. In 1989, there was a little storm that came through called Hugo, all right? Hugo was a hurricane, 140 mile per hour sustained winds when it came into the bay, okay? We lived through it, okay? We made it through. Just a big blow, all right? Hope I don't ever see another one. We operate 3 machines. Number 1 paper machine produces a variety of grades, okay? And by grades, I'm talking about thicknesses of paper, okay? From wallboard tape. Anybody build a house lately? Anybody build a house in the last 10 years? Okay? Wallboard tape is the tape that goes between your sheetrock. When you put the sheetrock up, you put the tape up. That paper comes from Georgetown, South Carolina. We are the world's only producer of wallboard tape. So please, build a house. All right? Number 2 paper machine produces primarily colored file folder stock. You go down to Staples or Office Depot or some of those places like that and you buy the colored file folders. Those of us that are still printing everything out, okay? You buy the colored file folders. Guess where they come from? They come from Georgetown, all right? We make 135 different colors. I may go in this morning and be making yellow paper on number 2 paper machine. When I leave this evening, we're making purple, It's just whatever color the customer demands. Number 3 paper machine produces fluff pulp. Fluff pulp is shipped all over the world. International Paper is a worldwide company. But our fluff pulp is shipped all over the world, both to end users and to other facilities to take our fluff pulp and make regular paper out of it in other countries, okay? Fluff pulp, that's where the conversation started with me and Procter & Gamble, all right? Fluff pulp is what is used in baby diapers and feminine products, okay? We ship it to them. They put more water in, do something to it. I don't know what they do to it, and they make baby diapers. Our fluff pulp has got to be top quality, okay? How many of you have ever held a baby? Anybody ever held a baby? Ever had his diaper to leak? That wasn't our pulp. All right. But Todd's from Procter & Gamble. He spoke earlier in the week. Todd and I were talking about it, and he was telling me about their process, okay? And, okay, it makes sense. So not only did I enjoy the presentations that have been made here, I've learned something about a customer, okay? A very valuable customer. We also purchased some of our electricity from Santee Cooper, and the following few slides, all right, and it is limited, guys, okay? This is a brief presentation. The following few slides are something that I found on a 115,000 volt line before we converted to 34.5. These photos were basically taken on a cool, partly sunny day in South Carolina. The relative humidity was low at 70%. All right. What does water and electricity do? If I put water with electricity, what happens? I get some kind of discharge, right? Normally, I will get a discharge of some sort. This is out, as you can see the pine trees and all behind us. This is where we pull from the 115,000 volt line that is supplied by Santee Cooper. Okay? You might say, well, Barry, that looks like a regular old distribution line. And it does. And it does. But it's extremely important to our facility. Okay? Once we pick the electricity up here, run it through a transformer, we convert it to 34.5, 34,500 volts, and it's transformed down to 2300 and 480 utilizing other transformers. The importance of this particular place, okay? Our pumps that supply water to our mill are 26 miles away. We have overhead line for 26 miles that we are responsible for maintaining. Okay? UE. All right, ultrasound. Ultrasound it's extremely important. I can take my long-range probe or long-range module, okay, and I can ride this canal, which I graciously do twice a year, down through the woods, all right, and follow the line and listen for electrical discharge of some sort, whether it's corona, tracking, God forbid, arcing, okay? We cannot afford for these pumps to go down. Paper is 90% water. We use 25 million gallons of water per day. All right, so it's real important. I walked up under this insulator, just a little digital camera, okay? Walked up under the insulator and took a picture. Pop. I'm looking for stuff to do this presentation on. If you'll notice, you can see, hopefully you can see just a little bit of darker color right there. These things are actually about 25 feet above my head. And I'm trying to see if I can see anything wrong. I'm trying to see it. So I move on. Okay, I'm gonna dig out my IR camera. Look at the temperature of the cable. The cable is actually about 49.2 degrees. 50-ish, okay? Happy, happy, right? Right? That ain't a loaded question. I'm not quite as bad as Dr. Neal. He asks hard questions. All right? 50-degree cable on a 50-degree day, I'm happy with that. All right, I can live with it. But if you look, all right, there's a hot spot apparently on the insulator. You got to look real close. I got better pictures. Okay? I got some better pictures. This is just another picture of the insulator. This, all right, is something totally different. I'm going to show you all our pictures, all this stuff in just a minute. Be patient. I go up here with my Ultra Probe, my UE 10,000. And when you walk in this substation, the noise is, I'm not going to say it's unreal, but the noise is extremely loud, okay? Even with my sensitivity set low, you can still hear things. This is one of the insulators up on top of the transformer, okay? Can y'all see that? Right there. What this is, let's see, let me get it right. It's aluminum cable that is steel reinforced. Okay? I've got an aluminum conductor in the middle, it's got steel on the outside. Now, you might say, well, Barry, that just looks like regular old cable. And agreed. All right, right there. but it jumps out, bang, whenever you walk in with the ultrasound probe. We've also got connectors right here, Ubolt style, the old style clamping connectors. Okay, guess what? Ideal place for discharge of some sort. This is the picture of the insulator I showed you. Remember the one I took the digital picture of looking up under it? When I took the picture and came back with my IR camera, the little black spots that we saw on the insulators were actually about 25 degrees hotter than the rest of the insulator. So what's that tell me? I'm standing there with my ultra probe and I can hear tracking happening. I can hear it. I take my IR camera and I can see it too. All right? It's neat to be able to hear and see. And that's what my IR camera allows me to do on these high voltage applications. Just a little closer view. If you look, right here is the same spot underneath the insulator, and here too. A Ubolt style connector. Look at the temperature difference there. Remember, I told you there was a possibility of having some kind of electrical discharge at the connection points for electricity. Okay? It's a good place to look. Look at your Ubolt connectors. All right? You can find stuff. My little pointer right there, my temperature pointer does not, well, I couldn't get it exactly where I wanted it. But you can see with the IR image that that cable is warmer than ambient. There is corona discharge going on inside that cable. Inside the cable. This was one of my very first finds when I come back to the mill with my brand new UE 10,000. Cool. All right. Go out there, Stephen Newell and I, which is he's another IE at the mill. We go out there and I said, Stephen, listen to this. We listening. Man, that's cool. We better panic. All right. So we go back to the mill and get up with our electrical reliability guy. Take Tim out there and say, Tim, come out here and listen to this. All right, keep in mind, this is like 7 miles away from the main facility. So we got to ride back out there. All right, it's a tough job. Somebody's got to do it. We go back out there. I hand Tim the UE probe. Say, listen. He listens. It's corona discharge. Well, we better call Santee since they supply it, right? We call Santee. Santee comes in with the bucket truck and 6 people, and oh boy, this is going to be fun. The guy goes up, looks at the cable, brings it back down. Actually puts in a new piece of cable, brings it down. Do any of you know what bird cage, anytime a cable is bird cage, do you know what I'm talking about? Cable is wound, okay? Electrical cable is wound, and it's wound tightly. The reason it's wound tightly, instead of just loose, especially on high voltage, is to decrease the probability of having electrical discharge. This cable, bird caged. It basically came unwound. Have you ever taken a piece of string and unwound it backwards? That's what I'm talking about. It's bird caged. There's electrical discharge going on between the steel outer jacket and the actual aluminum conductor. All right? The guy from Santee goes up. We look at our load. He says, don't worry about it. That's kind of a letdown. He said, no, don't worry about it. Your load isn't sufficient enough for it to actually cause you a problem. But it's called bird caged. Fuses. Have any of you ever looked at high voltage fuses? High voltage fuses way back there in the back? Have you ever looked at a high voltage fuse after it had been in service for a while? Outside. Okay? What did you see? Did you see fuzzes on the outside of the fuses? Little fuzzy things protruding out. These fuses, the case is made out of fiberglass. Normally, fiberglass or porcelain. Fiberglass fuses will give you a unique sound after they've been in service for a while. You've actually got corona discharge coming off all them thousands of little points. Okay? It's something else you can utilize the UE gun for. All right, your ultrasound device. Listen to it, you can hear it. That's the reason they paint these fuses, these high voltage fuses, with a shellac or a clear coat. It's so you won't have that. Another good place to look when you're doing your high voltage inspections. One of the things, and I'm winding up, one of the things on that I want to talk about with our mill, I utilize infrared technology, ultrasound technology, and by utilizing those two tools, okay, both together and separately, I increase my reliability. Our mechanics, the guys doing the rotating equipment assessments, they utilize the same tools I do, all right? They're not quite as avid as I am about ultrasound, but we're getting there. We're getting there, all right? It's a learning process, okay? It's something that's going to take time, but we're going to make it. Bottom line is I got to have increased reliability. Now, I can stand up here and talk about reliability all day long. I can put you to sleep, all right, talking about reliability. I'm not going to do that. All jokes aside, I want you to think about something, all right? What does reliability mean to you? What does it mean to you? Money. Money. All of us need money to survive, okay? If I can keep my mill running reliably, then I can continue to make a paycheck. And if I make a paycheck, I can have neat stuff. All right, I like stuff. Any questions?
On the wire that was aluminum casing, aluminum solid wire and a steel casing?
Yes, sir.
Was that braided wire?
No, sir, it's not braided, it's actually wound.
Wow.
The aluminum conductor, the actual aluminum conductor is inside and wound, and then the steel reinforcement is wound on the outside. Okay? The steel reinforcement is nothing but just something to keep the cable from pulling into.
So it's not braided?
No, sir. It's not a braided cable. No, sir.
All right. Thanks, sir.